Good morning to one and all. Last class we have discussed about different formulas related to the concepts of GMD and GMR. Today's class we will be going to discuss the problems regarding it, inductance calculations. Okay. The inductance formula expressed in geometrical mean radius for a single phase line is inductance per conductor per meter length is 2 into 10 to the power of 7 minus 7 log e dm by ds. What is dm? Geometrical mean distance. This is nothing but the self GMD. DS is nothing but the self GMD, and DM is nothing but the mutual GMD. Where the self GMD is having the formula of 0.7788 into R. We have derived that formula in the last classes, and DM is where the DM is the spacing between the conductors. Here it is the single phase line, so D is the spacing between the conductors. Coming to the single circuit three phase line, inductance per meter per phase per meter is equals to the same formula. Here the DM is nothing but the mutual GMD and DS is the self GMD. The formula for mutual GMD for the single phase single circuit three phase line is D here D1 D2 D3 root 3 3 root D1 D2 D3, where DS is equals to the same formula as such 0.7788 R. Okay, these are the formulas we have discussed in the last class. Double circuit three phase line is also the same, but here the mutual GMD formula is the formulas for self GMD and mutual GMD is this. We have derived each and every formula in the last classes. Okay, coming to the first problem. Now, the three conductors of a three-phase line are arranged at the corners of the triangle of sides 2 meters, 2.5 meters and 4.5 meters. Here, these are the corners of the triangle, and here the D12 is the distance of 2 meters here, and D23 is of distance 2.5 meters and D31 is of distance 4.5 meters. Now, let us calculate the inductance. What is here given? Calculate the inductance per kilometer of the line when the conductors are regularly transposed. When the conductors are regularly transposed, what would be the inductance per kilometer he had asked you. The diameter of each conductor he had given you as 1.24 centimeters. 1.24 centimeters. See here, whenever the conductors are regularly transposed, the formula would be, we have derived the formula. This I'll show once again in the previous slides. This is as such. We can see the formula like here. See here, the distance D is known as the equilateral spacing for unsymmetrical transposed line. Whenever the conductors are transposed, this would be the formula for it. What is the formula for it? This would be the formula for each line of the conductor. This is the formula. You can see here, this is the formula for it. This formula, if at all we substituted there, we'll be getting the inductance of each line of a conductor. So LA is equals to 10 to the power of minus 7, 0.5 plus 2 log E D by R Henry per meter. Let us see that here we are having this, the problem is given in such a way that the three conductors of a three-phase line are arranged at the corners of the triangle. Corners of the triangle of sides 2 meters, D12 is of 2 meters, D23 is of 2.5 centimeter, 2.5 meters, and D31 is of 4.5 meters. The conductor radius is of 1.24. Diameter he had given you, we have converted to radius. So D by 2 is nothing but the radius. R is equals to 1.24 by 2, which is nothing but 0.62 centimeters we are having. Now, equivalent spacing is, see here, 3 is equals to root D1, D2, D3 is the formula, equivalent distance spacing, right? So, here 3, what are the distances he had given you? One is D12 and another is D23 and another is D31 distance. These three distances he had given you. So, 3 root 2 into 2.5 and 4.5. We have to multiply so that you will be getting in meters. Okay. Now, if you want to change it to centimeters, so 282 centimeters we are having. Now, let us go for how to substitute these values in case of this inductance per phase per meter. 10 to the, this is the formula just now I have shown to you. The equivalent distance what we have obtained in the previous slide is that 282 centimeters we have got. See, this is the 282 centimeters we have obtained. So substitute this in that, and the radius is nothing but the 0.62 if at all in. This is the 0.62 value we are having for that of the, see, this is 0.62 in centimeters. This is nothing but the radius. After substituting these values, we'll be having the value of 12.74 into 10 to the power of minus 7 henries we are having. So if you want, this is for inductance per phase per meter. If you want to change for inductance per phase per kilometer, now what happens? This is multiplied with that of the 10 to the power of, into 1000 if you do, into 1000 if you do, it will be changes to the, see, this is the 1000, what it happens, 12 in 12.74, 12.74 into 10 to the power of minus 4 we are having. If at all we change it into the kilometers. Now, if you want to put this into the millihenries, now what it happens? 12.74 into 10 to the power of minus 4 we are having. See, the decimal has been changed to 1.274 millihenries into 10 to the power. Milli is nothing but 10 to the power of minus 3 Henry. This is how you need to simply substitute the values from the given data. Now later on go for the difficult problems so that you can understand better. This is the one. Next one is, now the question is given in such a way that calculate the inductance of each conductor in a three-phase, three-wire system when the conductors are arranged in a horizontal plane. When the conductors are arranged in the horizontal plane with spacing such that D31 is equals to 4 centimeters. See, the distance from here to here it is of 4 meters it is. Distance from here to here it is of 4 meters he had given you. See, this is the distance. D31 is the distance. Now, here D21 and D12 and D23 is of 2 centimeters he had given you. See, if it is, this one is D23 is 2 meters, what would be the D12? D12 is also 2 meters. Why? Because the total length is of 4 meters. Straight away he had given you in this question itself, D31 is equals to 4 and D12 is equals to D23 is equals to 2 meters he had given you. The conductors are here also, it is of transposed. Now for any transposed line, if at all we have, now if the conductors are transposed, the formula is inductance per phase per meter is, this is also the direct substitution, 10 to the power of minus 7, 0.5 plus 2 log E d by r. What is d? Here we are having three distances of an equilateral triangle. Okay, 3 root, D12, D23 and D31, that is 2 into this 4 distances multiplied, we will be having in centimeters like this. After substitution of these values, see, this is the D equivalent value what we are having in centimeters, 252, and this is the R we are having. He had given you in diameters, so 2.5 centimeters by 2 if at all we do, we will be having 1.25. If at all we substitute this in this formula, we will be having the answer as 11.1 into 10 to the power of minus 7 henries. This is how, this is for the conductors of transposed. Whenever the conductors are transposed, you need to straight away put this formula. Now, the problem will be in different way whenever we go for the, let us go for the next problem. See, this is also the inductance per phase per kilometer. If at all we want to change from meters to kilometer, we have to multiply with 1000 so that it is 10 to the power of minus 7 becomes minus 4. And if you want to write it in millihenries, then 1.11 into 1.11 millihenry it is. Okay. Now, this is very, very important problems. You have to, all of you try to write in one book. Take a paper and write. Two conductors, all of you listen to the question carefully. I will be reading it twice so that you can understand better. Two conductors of the single phase line. See here, we are having the two conductors. One is the conductor A and the other is the conductor B we are having. The conductor A and the conductor B we are having like this. Each of 1 centimeter diameter. Each of 1 centimeter diameter. The radius of this, each of this is nothing but the 1.5 centimeter. Okay, each conductor, conductor A and conductor B are placed like this. The diameter he had given you as 1 centimeter. What would be the radius? 1 by 2, so that it is of 0.5 centimeters he had given you as the radius of that. Okay, or arranged in a vertical plane with one conductor mounting 1 meter above the other. See, that is the 1 meter above the other means, see here we are having two conductors of a single phase line. What are the two conductors of a single phase line? A and A dash, B and B dash. It is a double circuit line, we can say. Single phase double circuit line, we can say. Now the arrangement is as such. Here the conductors are A dash and B, B dash. One is of 100 centimeters or 1 meter above from that of the other here given. If the diagram is not given also, you have to draw this diagram in such a way that by seeing the data. Okay. A second identical line is mounted at the same height. The second identical line is also mounted at the same height. That is, B and B dash distance is also same as the A and A dash distance he had given you. Okay, as the first. And spacing between the horizontal is, what is had given you? 0.25 meters. In centimeters, 25 centimeters it is. Okay, 25. If you change it to meters, 0.25 meters to centimeters, it is of 225 centimeters apart from itself. Apart from itself. The upper and the two lower, the two upper and the two lower conductors are connected in parallel. See, these two are parallel and these two are parallel. The upper and the two lower conductors are connected in parallel. Now, determine the inductance per kilometer of the resultant double circuit line. Double circuit line had given you. Here he asked you to find the inductance per kilometer of the resultant double circuit line. Here, since it is a double circuit line, we have the conductors A and A dash, B and B dash. Sometimes the diagram will not be given to you. So you have to draw the diagram by seeing the data. Okay, two conductors of a single phase line, each of 1 centimeter diameter, are arranged in a vertical plane with one conductor mounted 1 meter above the other. The second identical line is mounted at the same height as the first one and spaced horizontally 0.25 meters apart from itself. The two upper and the two lower conductors are connected in parallel. The two upper and the two lower conductors are connected in parallel to each other. Determine the inductance. In such a case, how to determine the inductance per kilometer of the resultant double circuit line we need to see. Now, see the conductors, they arranged the double circuit line arranged in a single phase is as such. This is the single phase double circuit line. By seeing the data, you have to know that it is of single phase double circuit line arrangement. You have to straight away do that and you have to draw the diagram by your own. Whenever the diagram, if suppose diagram is not given, since it is of single phase double circuit line, you have to draw like this. See here, in some of the cases, what would be see we have discussed in the last classes that the three-phase triple circuit line has been given like this. I'll show you the diagram so that you can understand better. See, this would be the diagram for the, I'll show you once again, wait. Yeah. See here, this is of the double circuit three-phase line. Double circuit three-phase line. Each of the phases, we are having the, three circuits, three-phase lines we are having. That means A dash, B dash and C dash we are having. This is the three-phase line. Phase 1, phase 2 and phase C. In three phases, we are having the double circuit line we are having. See, this is of the double circuit. A dash, B dash and C dash. This is for the three-phase double circuit line. But here in this question, what we are deriving now, this question comprises of, it is of single phase. In single phase itself, we are having the double circuit lines. That's why A dash and B dash is as such. Okay. Show the arrangement of the double circuit. The figure shows the arrangement of the double circuit single phase line. Conductors A dash. forms one connection and B dash forms the written path of the conductor. As the current you need to have the written path closed loop, so one is the written part of the other. Consider A dash forms the one connection and conductor B dash forms the written connection of it. What is the radius he had given you in the data? Radius he had given you 0.25 meters. If that is change it to the, which is nothing but over here, here it is of 1 by 2. So the diameter is been given over here. What is the diameter he had given you? 1 centimeter he had given you the diameter. 1 by 2, it is of 0.5 centimeters. The radius would be 0.5 centimeters. Now you have to find the self GMD and mutual GMD. How to find the self GMD? What do you mean by self GMD? Self GMD is the for the conductor A itself. For the conductor A itself. What is the formula for it? 0.7788 into R. What is R over here? We are having R is nothing but 0.5 centimeters we are having. So 0.7788 into this R is multiplied so that you will be getting, this is the self GMR of the conductor. Okay, GMR, geometrical mean radius of the conductor, which is nothing but, see this A and A dash, this diameter is nothing but 0.389. Okay, this is nothing but the self GMD of that particular conductor itself. Okay, this conductor. Okay, now it is of A dash and A dash A. These are the combinations what we are having for the self GMD. We have derived in the last class. This is the formula for self GMD. ds is equals to 4 root daa dash A. That means the distance from A is nothing but the self GMD 0.7788 R, which is nothing but this one 0.389 centimeters for DAA and DAA dash. This is the value. Okay, that's why we have got 2 times over here square we have done. So again A dash we have to see. A dash is how much? A dash is 100 centimeters he had given you, and here also B dash is given as, now we are calculating for one conductor A only. So here A dash and A dash A is also distance is A dash A from this stage. This is also the distance is of 100 centimeters. So 2 times we'll be having this 100 centimeters and 2 times we are having 0.389. Why we have 2 times here? Because for DAA and DA dash the self GMR is nothing but this value 0.7788 R, and this is the value for DAA dash and A dash A. It is from the diagram. A dash distance is 100 centimeters he had given you, and from A dash to A is also, this is also the distance from A dash to A is also 100 centimeters. So we have to multiply with 2 times. So 0.389 into 0.389 into 100 into 100, that makes you the square. So that this is on simplification, we have the value of 6.23 centimeters. That is the self GMD of the conductor A. Similarly for the conductor B, if at all you find what it happens, see this is nothing but 4 root DBB. Now DBB, this is of DBB. So see, I will write it here so that you can understand better. This is D actually. Now this is D. I am going to write DBB into D BB dash D BB dash into, in the same root itself, into D B dash into D B dash B. Okay, this is the formula as such. Instead of A we are having the B we are having. Now what is DBB? DBB is nothing but the GMR of that conductor B. What is the formula for that GMR of that conductor B? It is again 0.7788 R, which is nothing but R is nothing but the 1 centimeter we are having 0.7788 into, I mean, by 2 if at all we do, 1 by 2 is 0.5. Now this is the value for dB, dBB also. dBB is also the same value. And dBB dash, dBB dash, the distance is, these are parallel to each other. So the same distance from at the top, DAA is equals to DAA dash is equals to DBB dash is equals to 100 itself. So this is of value 100. This is of value 100 we are having. Now this value is also 100. So this is multiplied with 100, and here dB dash is the self of this B dash. So it is of having 0.389 centimeters. Here we are having how much? 0.389 we are having, right? Now dB dash B, from B dash to B we are having again 100 centimeters, the same distance. So into 100. The same how ds is equals to dA, ds1, which is nothing but for the self conductor of A, self GMD for the conductor A is equal to the self GMD of the conductor B also. So if we do this 2 root ds1 and ds2, what it happens? ds1 ds2 is nothing but 6.23, which is nothing but ds1 what we are having over here. Let us suppose the suffix 1 for the conductor A and ds2 for the conductor B. This is ds2, right? ds2 we can say. Now what happens? 6.23 into 6.23 whole power 1 by 2. Now what happens? It is again the value is same as this value. So now we are getting 6.23 centimeters itself we are having. That is nothing but the ds value, whatever you are having, that is nothing but the self GMD. This is how you need to calculate the self GMD values. Now next coming to the mutual GMD. How to calculate the mutual GMD? Now it is of the from DAB. What is DAB? Here we are having DAB is nothing but see A to B, it is of 25 centimeters. That's what we are putting here. This is nothing but 25 centimeters. DAB dash is what? AB dash is, see here, A into B dash. This is the thing we are having. A into B dash. This value 25 square plus 100 square. 25 square. See here, this is the value. A, this here we are having B dash. It is not, we are not able to see over here. See, A to B dash over here. So 25 square plus 100 square of this value you will be having. So that you will be getting what? 25 square plus 100 square, it gives you the value of 103. So we are having 2 times of it. DAB dash is 103 we are having over here, and DA dash B is also 103 we are having, but AB dash is of 25 centimeters. Similarly, B dash is also 25 centimeters. Why? The distance from A dash B dash is also same. Here, that's what we are writing over here. A dash B dash is also 25 only. So this on simplification, we have got this value. This is how you need to find the values for mutual GMD. Self GMD means for the same conductor itself, what are the combinations you have to take? Mutual GMD for other conductor, what are the combinations? For the conductor A to B, A B dash, A dash B and A dash B dash. Okay, this is how you need to do the problems. DAB dash is equals to DA dash B. Why? Because they are parallel to each other. So the values are same. So simplifying this, putting these values in this equation, 2 into 10 to the power of minus 7 log E dm by ds is equals to 2 into, see, what is dm? Dm is nothing but the mutual GMD. How much you have got? 50.74. What? How much you got? 50.74 centimeters. What is self you have got? 10 to the power of, 10, 6 point, this value we have obtained 6.23 into 6.23 centimeters. So we have been for 1 meter length, This is the value per conductance per conductor per meter length. This is the value of it. So this is the value in terms of henries. What is the units for inductance per conductor per meter? Henry per meter, we can say Henry. This is nothing but the Henry. The units for inductance is Henry. Okay. Now, if at all we change for kilometer, what it happens? Into what? 1000 we have to multiply. This we have done here. This is the 1000 we have multiplied. So that we have a millihenry. So that we have 2 into 0.42 into 10 to the power of minus 6 into 1000 Henry. That is equals to 0.84 millihenries, we can say. This is to loop inductance we are talking about. So we have to multiply it. Loop inductance. Please all of you mute your microphones. So here we are calculating loop inductance of it. So what to do? 2 into loop inductance formula is 2 into LA, where LA is this one. This is the formula for LA. 2 into this value, whatever the value we are obtained over here, that is multiplied. So that in terms of kilometers we are talking about. So multiply into 1000. So this is multiplied, then it becomes 0.84 millihenries. That is nothing but 10 to the power of minus 3, which is minus 3 in the sense milli. It is in terms of millihenries. This is how you need to. This is also a simple problem. Let us go for the little complicated one. Not complicated, it is easy only if at all you understand the concept. Very, very easy. Okay. Now coming to this problem. Problem is very, very important. Now here we can see that the figure 5 shows the spacing of a double circuit three-phase overhead line. The phase sequences is ABC and the line is completely transposed. The conductance of conductor radius in 1.3 centimeters. Find the inductance per phase per kilometer length. Here given you in the data that each conductor is of, see here, there is a, what it happened given, three-phase double circuit line. It is of three-phase double circuit line arrangement. Here he had given you A to C dash arrangement is 6 kilometers and A to B conductor it is of 3 meters and B to C it is of 3 meters. Sorry, it's meters. A to C dash is of 6 meters and A to B it is of 3 meters and B to C it is of 3 meters. That means the same distance is between the C dash to B dash and B dash to A dash over here. We have, so why? Because these are parallel to each other. Parallel to each other. This is of here given you. The diagram is given in your, question in the diagram is given in this fashion. If at all it is given, what we have to do for this such type of things? See, first of all we need to find the formula for. We need to find the derivative for. Substitute the values for self GMD. Self GMD is nothing but DS. Mutual GMD is nothing but DM. What is self GMD of that particular conductor? If at all we talk about of the conductor A, if at all we want to talk about. See, here the radius is given as 1.3 centimeters. Now here, see here, this radius straight away. The diameter is not given. Here he had given you the radius. Now what is the formula for self GMR of the conductor? GMR of the conductor is sometimes called as self GMD. Okay, self GMD of that conductor. See here for the conductor of this conductor A. What is self GMD? 0.7788 R, which is nothing but 0.7788 into what is the R he had given you? 1.3. Now it is of 0.77 into 1.3 value is this one 1.01 centimeters. 1.01 centimeters. Now how to find the distance of A to B dash? See, A is here and B dash over here. What is the distance? How to find the distance? See all of you carefully. The distance from here to here it is of 3 meters, right? 3 meters. From this to here it is of 6 meters he had given you in the data. From here to here he had given you the 6 meters. Now from this is the thing. What is the distance of it? Root over 6 square Pythagoras theorem plus 3 square. What would be the answer? 6 square plus 3 square gives you the 6.7 meters. 6.7 meters. Okay, that is changed into the meters over here. See here, these are the meters he had given you. In meters he had given you. So straight away you will be getting the answer as 6.7 meters. Now, what would be the distance from A to A dash? See, the A to A dash is, this is the thing, right? A to A dash. The total distance is this one, right? This is, what is the distance of it? 3 plus 3. It is of 6. What is the total distance? 3 plus 3. It is of 3 plus 3 from C to A dash is equals to how much it is? It is of 6. Value is 6. From C to A dash, it's the value of 6. We need to find the distance from A to A dash. A to A dash. What is this distance? 6 meters. This is also 6 meters we are having. 6 square plus 6 square, how much it gives? 8.48 meters. If at all we do simplify and calculate, you will be getting the answer as 8.48. This is how you need to find the distances from each of the conductor to that of the other conductor. Each of the conductor to that of the other conductor. Distance from A to A dash is this much, and similarly from B to B dash is how much? B to B dash is again 6. Okay, C to C dash is again same as that of, see here. All of you listen to me carefully. C to C dash is the 6. See, this is the 6 distance. Okay, sorry, this is the root over 6 square plus 6 square. This is also 6 square plus 6 square plus 6 square. Depending on the position of at what place it is placed. So depending upon the distance, you need to find the distance from one conductor to the other. C to C dash again gives you the value, this one, 8.48 meters. Okay. Now you can observe clearly that B to B dash is again 6 only. It is parallel. So this is of, here these are placed like this. B is over here and B dash over here. What is the distance? The distance is same as A to C dash. Okay, A to C dash. Like this, you have to analyze from the diagram. You have to analyze the diagram. You have to analyze the diagram. You have to find the distances from each and every of the point. Distances from each and every of the point to that of the other. So that it will be very easy to find the self-GMD as well as the mutual GMD. One thing you need to remember is, if at all we find the GMR of the conductor, which is of the self-conductor, that is AA, DAA if you want to find, then this would be the formula. DA dash A dash. Now this would be the formula. BB, DBB is also this formula only. B dash is also same. 0.7788 into R. Now, if at all you want to find the A to A dash, we have to look for the diagram. You have to look for the diagram. Here A is present and A dash is present over here. If it is self, then self-GMR of the conductor would be this one, 0.7788 into R. If you want to find the distance from A to A dash, A dash, now it differs, that is nothing but we have to see the distance of this, and you have to find the distance from this. Root over 6 square plus 6 square gives you this value. Like this, you have to find for each and every of the conductor, so that it will be easy for you to do the problem. Equivalent self-GMR of one phase is DS is equals to, what is the formula? Here we are having the 3 conductors ABC or double circuit conductor, double circuit lines we are having. So 3 root DS1, DS2 and DS3. Why? Because we are having conductor A, conductor B and conductor C. You have to find the self-GMD for this conductor A. You have to find the self-GMD for this conductor B as well as the self-GMD for this conductor C. You need to find like that. Okay. Conductance, self-GMD of one phase if you want to find. See, what would be the DS1? DS1 is as such. What is this DS1? How many are there? DAA. What are the combinations we are having over here? See, D2, DAA is one combination itself. DA dash A dash is one combination. DA to A dash is another combination. And A dash to A is other combination. These are the 4 combinational distances we are having. So, the self-GMD DS1 is equals to 4 root DAA into DAA dash into DA dash A dash into DA dash A. This is how you need to see depending upon the number of connections we are having. There are 4 connections of 4 root. So how would you get this one? DAA is equals to how much we have got this here? DAA is equals to what? The self of this is nothing but 1.01 centimeters. So it is of 1.01. If you want to convert this centimeters to meters into 10 to the power of minus 2. This is in meters now. Now it is of AA dash. AA dash distance we have found out here what? AA dash is equals to 8.48 meters we are having. In meters we are calculating. So this is of 8.48 meters. Now again the self of it we are finding. The self of it is same as that of this. A dash is nothing but 0.7788 into R. If at all you multiply this, this is the value for this D A dash. Okay. And A dash A is again the same as that of the AA dash. Why? Because there are equidistance from each other as that of the one another. So we are having this value. So if you simplify this one, you will be getting the value of 0.292 meters. That is equal to, see, one thing you need to understand from this diagram, you have to see the diagram that A and C are having the same one. A and C having the same distances. But B is of distance of 6 meters, whereas C dash is of distance of root 6 square plus 6 square. All of you able to understand? Root 6 square plus 6 square value is 8.48. But here B dash distance is only 6. Here A dash distance and C dash distance is different. 6 square plus 6 square from the diagram. If you examine this diagram carefully, you can understand the distances of each and every of this. This is very, very important while doing the problems. In order to find the distances from each other to finding the self GMD and as well as the mutual GMD. Now see, since DS1 is equals to DS2 as the same as that of the DS2. Why? Because 4 root, again we are having DCC. See here, I will be calculating here, all of you listen to me. DCC into D C dash into D C dash into D means C dash C we are having. Okay, this is C. We can write over here. This is C. The same way as this formula. Instead of here we are placing C. But here, whatever the value we are obtained over here, that the same value we obtained over here. Why? Why is it so? See this diagram. See, A and C are at equal positions. A and C are at equal positions. See, C A dash, A C dash. So the combinations, in this combinations, we will be getting the same value as that of the DS1 is same as that of the DS3. But here in the case of DS2, it is of different. It is of 4 into root over dBB into dBB dash into dB dash B dash into dB dash B. How it will be? dBB is nothing but the self GMR, that is GMR of the conductor, is the same as that of the 0.7788 into R, the radius multiplied with the same as over here. Okay, but D into B dash is different. Why? B dash distance is 6 only. See here, the distance from B to B dash is 6 meters only. Here B to B dash distance is 6 meters only. We can say straight away. That is that we have kept over here. B dash is nothing but 1.04. B dash is the self of it. That is nothing but putting in the formula what? 0.7788 into R. 88 into R is the value. What is the R value we are having? R is nothing but how much we are having over here? 1.3. R is given as 1.3 because straight away put in place of R into 1.3. If at all you put, you will be getting the same answer. You will be getting the Same answer as that of this. This is the value of that. Now d b dash b dash. I mean d b dash b we are having. See d b dash b is nothing but from b dash to b. What is the distance? This is the distance we are having. Same as that this distance, that is nothing but the 6 meters we are having. So that 6 only we have kept over here. Now finally it
Ma'am,
will give you, yeah.
ma'am, అక్కడ DIA nothing but GMR of the conductor, ma'am.
Yes, ma'am. Yes, GMR is nothing but the diameter of the particular conductor, self GMR. GMR is nothing, sometimes called as self GMR. Okay, its formula is 0.7788 into R. If at all you are finding the value for DAA suffix, all of you examine the suffix, which is nothing but DAA, A dash, A dash. Wherever you are having the same suffixes, see, A dash, A dash. In that cases, we will be putting this formula. Okay, it is of self formula. Wherever you are having A dash, okay, the conductor A and A dash A, you will be seeing this. I mean, self of this is nothing but this formula, ma. Okay. Now, A dash into A, if at all you find out, now you have to see the distance, actual distance, whatever the distance you are having. From this to here, from here to here, what is the distance? 6 square plus 6 square,
6
right?
square.
Yeah, that is nothing but 8.48 meters,
4
right?
meters.
8.48 meters. That distance only you have kept. Here, BB dash is how much is the distance? See, all of you, BB dash, how much is the distance? Same as
6.
the distance of, yeah, very good. A and C dash distance is same as that of the B and B dash distance. So 6 I have kept. Here I have kept 6. That is why. Self, we have, if at all we are having the suffixes same BB and B dash B dash, C dash C dash means we have to put this formula. Why? Because GMR means self GMD of that particular conductor itself is the formula is 0.7788 into R. But if at all we do for one A to, I mean B to B dash, if at all we see by seeing the diagram, you have to see the actual distance of it and you have to put it. In the same way, you have to find the, now three combinations we are having. What are this? Understood? DS1, DS2 and DS3 we are having. What is the value for DS1 we are having over here?
0.292.
0.292. What is DS2 we are having? 0.246. Very good. Now what is the value for DS3 we are having? Same as DS1. Why? Because the distances are same. See, C and C dash are at equiposition to each other. Here these are parallel to this. This is at same position to that of the C dash. Here C is same position to that of the A dash. So if at all you find the distance of it, here 6. So that root over 6 square plus 6 square. Here also you are getting the same answer as that of the conductor A. So we are placing over here like that. So we are having DS1 is equals to same as that of the DS3. DS2 is this one. So you have to multiply all the three. Okay, multiply all the three with 3 root. Here we are having 3 DST combinations. 3 circuit, okay, double circuit, 3 phase lines. So 3 combinations we are having, so 3 root. So 0.275 meters. This is how you need to find the self GMD. What do you mean by DS? DS is nothing but the self GMD. What is it called? Self GMD. What is it called? Self GMD we can call it as. Okay, which is nothing but the self GMD. Self GMD. Okay, this self geometrical mean distance, sometimes called as GMR, we can say. Now coming to the mutual GMD. What is the formula for mutual GMD? Mutual GMD DM is equals to, it is the mutual distance between the one conductor to the other conductor, not by itself. See here in the self GMD we have taken the combinations of only B conductor, only A conductor and only C conductor. But here in the case of the mutual GMD, we are taking the distances from one conductor to that of the other conductor we are talking about. So it is of mutual GMD DM, that is equals to 3 root DAB, DBC and DCA. How could you find this? We will be going to see in this class. Okay. Now in this slide, DAB is equals to, this is the distances. What is the distance of DAB? DAB is, see the diagram, DAB. What is DAB? See, this is the 3 meters. DAB is 3 meters. That only I had written over here, 3. Okay. And D into AB dash. DAB dash is how much? DAB dash we have found. AB dash is nothing but A, B dash is over here. What is the distance? 6 square plus 3 square root. What is it? 6 square plus 3 square distance is this one. What is it having? We are having 6.7 meters we are having. So that is the thing I had written over here. Say 6.7. Similarly, A dash B is also the same 6.7. And here we are having A dash B dash. See, if you see the diagram is very important. A dash B dash. Where is A dash? Here is the A dash. And B dash is where? Here is this. What is the distance of it? Only 3. Distance of it is 3 meters. So you will put straight away 3 meters over here. Like this, by seeing the diagram, you have to put the value of each and every of the element value you have to put, and you need to find the value of 4.48 meters and DBC. Again, you need to find DCA value. In the same way, these are the combinations. CA, CA dash, C dash A and C dash A dash. By seeing the diagram, CA is how much? If you see the diagram, see CA is how much? C to A, what is the distance? This is the distance. What is the distance? C to A, it is of 6 meters. It is of 6 meters. That's why I have kept 6 meters over here. What is the distance of DCA dash? See, here also we'll be seeing once again CA dash. Here, C, this is nothing but A C dash is nothing but 6 kilometers. C dash is again is nothing but meters. A dash A C dash is 6 meters, ma. C dash is also has 6 meters, okay. And CC dash is nothing but the 6. CC dash is again we are having the 6 meters. So this is the combination. Like this, you have to put the value of. CC dash is not comes over here. Here in the self GMD we are having C dash A is called C dash A dash combination. What is C dash A dash combination? C dash over here, A dash over here. What is the distance of it? 3 plus 3, 6. All are 6 over here in this. All are 6. So 6, 6, 6, 6 multiplied and 4 root. So whole power 1 by 4, you will be giving again 6 meters. In the same way, DAB is equal to DBC. If you substitute these values, you will be getting the mutual GMD. I mean, self GMD and mutual GMD, right? Self GMD is abbreviated as DS and mutual GMD is abbreviated as DM. Mutual GMD is abbreviated as DM. So simply substitute in this formula. 10 to the power of minus 7 into 2 into log E DM by DS. What is the DM value you are be having? 4.94 you are having. That's what I have kept over here. That is the thing. What is the self GMD we are having? See, we'll be seeing in the slides. What the self GMD is nothing but 0.275. That's the value I've kept over here. After finding, you'll be having. See, wherever you are finding, there is a meter length. If at all you want to change into the kilometers, into 1000 you have to do. If you want to change into milliamperes, now we'll be going for the 10 to the power of minus 3 we'll be having. So 0. Here 7 into 1000 becomes minus 4. Minus 4 into 10 to the power of minus 4. If you want to change it to the milliamperes, 10 to the power of minus 3, 0.1 decimal goes to here. So it is of 0.57 milliamperes. Okay. In the last class, in the next class, we'll be going to discuss about if the conductors are placed. See here, in these diagrams, wherever we are come across in this today's class, we are having the distances nearly equal. These conductors are placed equal to these conductors. Why? Because these are parallel to each other. In the next class, we are going to discuss whenever there are different placements. Okay, the distance is not the same. Here, this distance is not the same as distance. AC dash distance is not the same as that of the BB dash distance. Here, CC dash distance is also, these two are equal, but this is of more distance, 5.5. In such case, how could you solve this problems of GMD and GMR, self GMD and GMR? How could you find the inductances? We'll be going to discuss in the next class, which are very, very important. These will come in gate also. This is where who are interested to go for the gate. Those who are interested. So please, all of you try to listen the classes very carefully so that you will understand better. Okay. Thank you, one and all. Today's class, we'll close the session and we'll go for the doubts clarification.